Welcome to my video series for Algebra 2 Semester 1. These videos will help you prepare for your quizzes and tests. This first section is algebraic expressions. First of all, what is an algebraic expression? An algebraic expression is a mathematical expression with one or more variables. The difference between an algebraic expression and an algebraic equation is the algebraic equation has an equal sign. So in this first section, they want us to write each as an algebraic expression. So the first one says the sum of 5 and a number squared. Well, first of all, let's look at the word sum. We know sum means add. So we know this is an addition. So what we're going to do is just do it right in order. The sum of 5, so we'll write our 5, and wherever you see the and, that's where we would put a plus sign because we're doing sum. So 5 plus a number squared. A number, we don't know what it is, so we use what we call a variable. It's like a placeholder. So in this case, we'll use x. And squared, that means to the power of 2. So we would have 5 plus x squared. That would be our algebraic expression. So the next one, it says 5 less than a number. Now less than, we know means subtract. So 5 less than a number. This one's a little tricky because we want 5 lower than a number. And again, a number, we don't know what it is, so we use x. And we want to subtract 5 from that because we want 5 less than a number. So if the number was 10, if we wanted 5 less than it, we would subtract 5 from it and we would get 5. So x minus 5 would be our answer. The next one, the product of 4 and a number. Well, product we know means multiply. So again, wherever the and is where we're going to put a multiply sign. So the product of 4 and a number, where and is, we'd put multiply. And a number, again, we don't know what that number is, so we write x. So it'd be 4 times x, or just 4x. And then the quotient of a number and 5 minus 3. Well, we know quotient means division. So again, wherever the and is, right after the quotient, wherever the and is, we're going to put a divide sign. So we're going to take x divided by 5, and then it says minus 3, and minus means subtract. So minus 3. So we'd have x divided by 5 minus 3. And the next one, we have 3 times the sum of 5 and a number. So this time, times we know means multiply. So we have 3 times. So we have 3 times sum we know means add. So wherever the and sign is, we're going to put a plus sign. So it's 3 times 5 plus a number, and we don't know what that number is. But because we want to multiply 3 times the sum of 5 and a number, we need parentheses because we have to add 5 plus x first. Then we multiply by 3 because we want to multiply 3 times the sum of 5 plus x. All right, and let's see what we have next. So the next section we have, find the algebraic expression that best describes the sequences. So in this case, they want us to find an algebraic expression based off these numbers. So the first one we have 8 16, 24, 32, and 40. So the first thing we want to do is look at the difference between these. So between 16 and 8, it's 8. Between 24 and 16, again, that's 8. And then between 32 and 24 is 8. So there's a pattern. It's 8 between each number. So our equation would be 8 times x. 8 times x. Because if we check this to see if we're right, this 8 is our first term. So that's our number 1. 16 would be our second term. 24 would be our third. 32 would be our fourth. And then 40 would be our fifth. So if we take those numbers, 8 times 1 would give us 8. And then 8 times 2 would give us 16. 8 times 3 would give us 24. So if we keep just plugging in these numbers, the 4 into the 8 is 32. 5 into 8 would be 40. So we just keep plugging those in. We know our equation is right because we checked it and it works. So the second one, if we take 1/5, 2/5, 3/5, 4/5, and we need to find an algebraic expression. Well, if we look, the denominator is always staying the same. So in our equation, our denominator should be the same. It should be 5. The only thing that's changing is the top. And if you notice, it's going in sequence 1, 2, 3, 4. So our numerator, we don't know, would be our variable, which is our x. So again, if we plugged in 1 and then 2, then 3, then 4, we'd end up with these numbers. So the next number after 4, we could plug in 5, which would give us 5 over 5. And then if we plugged in the next number, which is 6, we'd have 6 over 5. So the pattern keeps going if we increase the number by 1. So x over 5 would be our algebraic expression. And now let's look at the next section. Find an algebraic expression for the table. So this time we have steps we can follow. So let's look at these steps. All right, so the first thing we want to do is find the difference of all the y values. So this column is our y column, and if we're going to find them, so we need the difference between 9 and 12, 12 and 15, and 15 and 18. So between 9 and 12, we know it's 3. Between 12 and 15 is 3, and 15 and 18 is 3. So 3 would be the difference. Then it says multiply the difference by x. So we know our difference is 3, and if we multiply by x, we end up with 3x. Then it wants to know what is the constant that would fit the pattern. All right, so what we're going to do is take our x value this time and plug it in to the 3 times x. So we take the first one, plug in 2 in place of x, we'd have 3 times 2, which gives us 6. What would I have to add to 6 to get me to the y value of 9? I would have to add 3. So 6 plus 3 equals 9. And let's try the second one just to make sure. So this time we're going to plug in the 3. So then I would have 3 times 3, which 3 times 3 we know equals 9. And what would I have to add to 9 to get 12? Well, you'd have to add 3. So 9 plus 3 gives me 12. So 3 is the number that we had to add to both of them to get to the y value. So 3 is our constant. And again, a constant is a value with no variable. So then it says write your expression. Well, we know in step 2 there, we had 3x. And then our constant would be, we added 3 to that. So our expression would be 3x plus 3. And if we wanted, we could check. Let's try number 4. If we took 3 times 4 plus 3, what would we end up with? Well, 3 times 4 is 12. 12 plus 3 is 15. And that's what we're supposed to get. So where x is 4, y would be 15. And it works out. All right, so let's move on to the next. So in this step, it says, what is the algebraic expression that best describes the monthly salary? So this one, what we need to do is find out what the difference is in the y values. So in this case, between 1200 and 1100, there's a difference of 100. And between 1200 and 1300 is 100, and 13 to 14 is 100. So we know that this is going up by 100. And we know this one, 10 to 20, that would be 10. 20 to 30, that would be 10. And 30 to 40, that's 10. So this is the x, or this side is going up by 100, or tens. Now, the thing we need to know is, where did we start? If we went backwards on both of these, so this is going to be 0, and we went back 10, because between 0 and 10 is 10, we'd have to do the same thing here, or on this side. If it's moving up by 100, if I want to go backwards, I would go back 100. And if I go back 100, 1100 minus 100 would give me 1,000. So at 0 training hours, my monthly salary would be $1,000. So $1,000 is where we started at. That is our constant. It's our starting point. So we know $1,000, that's our constant. All right, so we figured that out. And now under the training hours, we know as the training hours go up, the salary increases. So what we want to do is, the training hours are going up by 10. And the monthly salary goes up by 100. If we take 100, divide that by 10, 100 divided by 10 would give us 10. So for every hour that we have a training hour, we increase our salary by $10. All right, so it's $10 per hour. All right, and we don't, theoretically, we don't know how many hours, because you know that we have. So we're going to make that our x. So 10 times how many hours we worked, so 10x, and our starting point was 1,000. All right, so let's see if this works. Let's take our 10 hours here and plug it in for x. So we have 10 times 10 plus 1,000. Now 10 times 10, that's 100. And 100 plus 1,000, that's 1,100. And that's exactly what we were looking for, $1,100 right there. So 1,100. So let's try one more. Let's try 20 just to make sure. So 10 times 20 plus 1,000. So 10 times 20 is 200. 200 plus 1,000 is 1,200. And that's what we were looking for, 1,200. So we know that our expression is 10x plus 1,000. That's our expression. Okay, and the next one, it says find the algebraic expression that corresponds to the following chart. This chart is off just a hair. This should be, oops, it should be 5 comma 10. This should be 10 comma 20. And this should be what, 15 comma 30. So it just, some reason my line moved up just a hair. And 20 comma 40. And they want us to find an algebraic expression. So what we need to do is figure out what we'd have to multiply, divide, add, or subtract from the x to end up with the y. So if I have y equals something times x, let's say. If my y is 10, what would I have to multiply x by to get 10? Well, we know x is 5. So what do you have to multiply 5 by to get to 10? Well, you'd have to do 2. 2 times 5 gives me 10. All right, so right now, I know it's 2x. All right, so let's try another one. Use the same thing, 2x. So if I take the second one here, this one, 2 times 10 equals 2 times 10 is 20. And that's exactly what the y value is right there. It's 20. And let's try the next one. So 2 times 15 equals 30. And right there it is. That's what we wanted it to equal. So in this one, our expression is just 2x, because we had to multiply the x by 2 in order to get the y. And remember, when we do this, x is the first value, y is the second value of a coordinate. All right. So all you got to do is figure out what do you have to do to the x to get the y. So on a graph. All right. And the next thing. So this one, it says, what is the coefficient of these algebraic expressions? So first of all, coefficient. Coefficient is the number in front of a variable. So this first one here, we have 6xy. So what number's in front of the variables? Well, it's 6. So 6 would be our coefficient. The next one, we have 3x plus y squared. Well, in front of the x, we have a 3. So that's our coefficient. In front of the y, though, there's an imaginary 1 in front of the y. So we'd also have 1 as a coefficient, because there's 1 in front of that y. There's always a imaginary 1 if there's no number. So if I, yeah. All right, and then the next one. How many terms are in the algebraic expression? Terms are, this would be one term, this would be another term. So wherever there's a sign, that separates your terms. All right, so in this one, the first one, we would have 2 terms. 6x is one term and 3 is the other term. So remember, the signs separate your terms. So the second one, you'd have 1 term, 2 terms, 3 terms. And the third one here, you'd have 1, 2, 3, 4, 5. So you'd have 5 terms. So remember, the signs separate the terms. And for this video, that's about it. Thank you for watching. And if you liked it, please give me a thumbs up.